Hello. So let us start today's session. Welcome you to the great live mentoring session, phase 2, and week 5. So let's move into the first question of today. I am audible, right, Sanjit?
Yes, sir, you're audible.
Okay. So let us move to the first question of today. This is the question number 30 of GATE 2012 Metallurgical Engineering. The question is, for an FCC metal, the ratio of interplanar spacing obtained from the first two peak of the extracted diffraction pattern is option A 1.91, option B 1.63, option C 1.41, and option D 1.15. So, do you want to approach how to solve this question? This is a very easy question, by the
Yes, sir, we know the ratios of h square plus k square and l square. So according to that, we can solve it.
way. Yes. So, for an FCC metal, what will be the first peak? Let's say this is the intensity versus 2 theta. In case of FCC, uh, the peak distribution is like this, right? Okay. So, what will be the first peak?
So it will be at 111,
111. And the second peak?
20. No, sir, it will be at 200.
200. Do you know the H squared plus K squared plus L square sequence for FCC?
Sir, it's in pairs, sir, like 3 is to 4, then 8, then 11 is to 12.
3, 4, 8, then 11, then 12. So like this. Okay. So first one is 3, that is 111. Second one is 4, 200. And third one will be 8. That means 220. Right. And the fourth one will be 311. And the fifth one will be 222. So like this, the peaks are distributed for an FCC metal. Okay, so we need to find out the ratio of the interplanar spacing. So interplanar spacing, that is D, is written as DHKL, is lattice parameter divided by root over of h square plus k square plus L square for a FCC metal, phase center cube. Okay, so now we need to find out the DHKL for the first and peak and for the second peak. So for the first peak, it will be D111 is equal to A by, and for the second peak, it will be D200, that is equal to A by root over of 2 square plus 0 square plus 0 square. So A is constant for a fixed FCC crystal. So if we simply take the ratio of this one and this one, so D111 divided by D200 will get root over of 4 divided by root over of 3. So can you check and let me know how much it is coming?
Sir, around 1.15.
1.15. Chanta, you joined a bit late, so you can see this slide. If you don't understand, just let me know, so I will explain again.
Okay, sir.
Okay. So basically, if you know the exact peak distribution for an FCC metal, how those are distributed. So the sequence of h square plus k square plus l square is 3, 4, 8, 11, 12, like this. So this concept also I have covered in one previous session also. Why this kind of distribution follows for FCC. This is for FCC. For BCC, it is 2, 4, 6, 8, like this. So this concept also I have covered in previous one of the previous session. So you can follow that. If you don't understand, just you can ask me in the next session also. So for FCC, this sequence is this one. So now it was asked to calculate the interplanar spacing, the ratio of the interplanar spacing obtained from the first two peak. So that means 3 and 4. So first peak is 111 and second peak is 200. So DHKL is equal to A by root over of h square plus k square plus L square. So using this formula, you can calculate the ratio. Is it clear?
Yes, sir.
Okay. So the correct answer is option D. Okay. So now let us move to the next question of today. Hmm. So this is the question number 42 of GATE 2018 Metallurgical Engineering. The question states that pure iron transforms from body-centered cubic to a face-centered cubic crystal at 912 degrees centigrade. If the lattice parameter of the BCC phase is 0.293 nanometer and that of the FCC phase is 0.363 nanometer, the associated volume change is in percentage of one decimal place. You have to find out. Okay, so for the question states that pure iron, it was initially in the BCC form. So, initially it was in the BCC, and then when you were raising the temperature at above the 912 degree or at 912 degree centigrade, it is transferring into FCC crystal. So you need to find out what is the volume changes that is associated for this transformation. So this crystal structure is transforming to FCC. So these are the distribution of the atoms in the BCC and FCC crystal structure. So in case of BCC, how many atoms you have per unit cell?
2, sir.
2. And in case of FCC,
4.
4. Okay. Is it clear to you also, Ajanta?
Yes, sir.
Yes. So in case of BCC, you have 2 atoms per unit cell, and in case of FCC, you have 4 atoms per unit cell. So now, the lattice parameter is also given. So when the structure was BCC, your lattice parameter was 0.293 nanometer, and when it converted to FCC, the lattice parameter increases a bit. So in this case, it is 0.6363 nanometer. Okay. So now we have to find out what is the volume change that is associated. So any one of you can approach how to proceed. So now you have all the informations like lattice parameter for BCC.
So it's a cubic unit cell. So like volume of any cube is
Mhm.
the raised to the power 3 of its lattice parameter value.
Yes.
And then since the number of atoms are different, so we
Mhm.
need to equalize them. So we will divide by the effective number of atoms and then we can compare.
Yes, exactly. You are right. So in case of, you can see that in case of BCC, you initially you have 2 atoms per unit cell. Now in case of FCC, you have 4 atoms per unit cell. So that means 2 BCC unit cell is converting or transforming into 1 FCC unit cell. Okay, because you have to equate the number of atoms also which are accommodated in a unit cell. So 2 BCC unit cell will transform and give rise to 1 FCC unit cell. So this will transform and will give rise to 1 FCC unit cell. Eight atoms at the corner and 6 atoms at the face center. So in this case you have 4 atoms per cell. In this case 2 atom, sorry, 2 atom for this cell plus 2 atom for this unit cell. So basically 2 unit cell is transforming to 1 FCC unit cell. Okay, so now you can find out the initial volume and the final volume, and then you can easily get the what is the volume change that is associated. See, what was the initial volume? V1, you can write the initial volume was 2 into volume of 1 BCC unit cell, right? So now volume of BCC unit cell, how much? Because already the lattice parameter is given to you, so the volume is simply a cube, right? The lattice parameter is a, so the volume is a cube. So a for BCC it is 0.293 whole cube. I am not converting the uh, that in meter because if I will keep both in the nanometer unit, so you can go with this also, because if you keep the both units in the same, then you will, when you are making the ratio, that will automatically get cancelled out. So just take care of this unit. uh, don't change, for one you change in meter and for another if you keep in nanometer, then you will get wrong answer. Okay, so in this case we were earlier that initial volume of the unit cell was, so 2 into 0.293 whole cube. Can anyone let me know how much you are getting this one?
So it's 0.05.
Okay, so
Yes, sir.
0.05. Okay, and what will be the final volume? V2, that will be the volume of volume of one FCC unit cell, right? Because two BCC is transforming into one FCC. So in this case, what will be your volume? Simply a lattice parameter of FCC whole cube. So what will be the volume then? 0.636 whole cube. It will be in nanometer cube. Okay. So how much this is coming?
0.047, 0.048, sir.
0.048. So here the unit also nanometer cube. Okay. So now you have to change the percentage. You have to calculate in percentage up to 1 decimal point. So what will be the volume change? So percentage of volume change, it will be V2 minus V1 divided by V1 into 100, right? So this is 0.048 minus 0.05 divided by initial was 0.05 into 100. So how much it is coming?
Sir, around 4%.
Okay, let me check also. Okay, so it is coming minus 0.04 into 100. That means around minus 4%. Okay, are you also getting the same answer? So also keep in mind to write this minus also. Okay, if you write only 4%, then you will not get mark, because in this case when it is transforming from BCC to FCC, your volume is basically volume is decreasing, so contraction is taking place, right? So just only seeing the lattice parameter, you may think that the volume expansion is taking place, but this is not the case, because two BCC is transforming to one FCC. So that's why ultimately what you will find that your volume uh, contraction is happening, not expansion. Is it clear?
Yes, sir.
Okay. Uh,
Sir, like suppose here,
yes.
if we think practically, then uh, when if we are working, a billet is getting worked, is getting hot worked,
Okay.
then like after crossing a temperature of this 912 degrees Celsius, it
Hmm.
is converting from FCC to BCC.
Yes.
So there is a corresponding increase in the volume. So that will sir like lead to the distortion of that workpiece, no? Or like whatever design we intend, like it should be of length, suppose say 4 meters, but it should be a bit larger than 4 meters due to this increase in the volume.
Okay, you are saying that when the temperature is decreasing from 900 below 912, so then it will convert from FCC to BCC. So
Yes, sir.
volume expansion will take place a little bit, right?
Yes, sir. Yes, sir.
Okay, okay. So like uh, in that case, like that's why that most of the hot metalworking that is done at the above your that AC1 temperature, means in the FCC region, not in the BCC region, because that work ability will be good in case when the structure is FCC. Okay, because more number of sleep system will be there, and activated sleep system will be there. So in case of BCC, with that hot working, that's why means in BCC that when you will do the hot working, so means that percentage of that reduction will not be much. So that's why people do the reduction at FCC only. Okay, so and you are. Can you just reframe your question once again? Like so.
So means like I mean to say
Hmm.
that if we are hot working it at a certain temperature,
Okay.
and we say that this length of the billet after getting hot worked should be 4 meters. It
Okay.
is four
Okay.
meters, but
Okay.
like suppose my rolling is finished at a temperature which is like at say 930 degrees Celsius. Now
Hmm.
at 930 degrees Celsius, the length of that billet was 4 meters as we had already planned. But
Yes.
after it is cooled, like then
Hmm.
there would be a expansion. So its length will increase from 4 meters, like which we do not intend to achieve.
Yes, yes, yes. So that will happen. So if you want to take care of that, then you have to calculate accordingly. So that what should be your length when you are working in FCC region, so that when it will cool down and convert into BCC, what will be the final length? Okay.
Okay, sir. Okay, sir.
Yes, yes. So then, if it is clear, then should I move to the next question?
Yes, sir.
Okay, so this is the question number 48 and 49 of GATE 2013 Metallurgical Engineering. So this is a common statement for this both questions 48 and 49. So the statement that is given is a steel specimen containing 0.28% carbon is carburized in an atmosphere that maintains a carbon content of 1.28% at the surface of the specimen, and the data are given that for carbon diffusion in austenite. So d naught is given. D naught is 2 into 10 to the power minus 5 meter square per second, and the activation energy for diffusion, that is 142 kilojoule per mole. And also one chart is given for the y values and the corresponding error function of y. And then the first question is 48, question number 48. So the question is, what is the depth in micrometer from the surface of the specimen at which a composition of 0.48% of carbon is obtained after carburizing at 870 degrees centigrade for 10 hours? Okay. So let's say this is your specimen, so which is having 0.2 weight percent of carbon. Okay, so now carburizing is taking place. So at the when the is taking place, then at the surface of your specimen 1.2 weight percent carbon concentration is maintained. So let's say here a carbon concentration of 1.2 weight percent is maintained. Okay, sorry. And then the first question that is asked. So in first question it is asked that after 10 hours and at 870 degrees centigrade, what will be the what will be the distance where your compositions of the carbon will be 0.4. So here your composition is 1.2. So corresponding this to this line, here your concentration is 1.2, and let's say somewhere here it is 0.2. Okay, so that means your concentration gradient will be like this. So with time it will go like this. Okay, so like, so let's say this is for a time t1, this is for time t2, and this is for time t3. So the profile will goes on like this. So here it will always maintain 1.2, and at the very infinite distance uh, from your interface, the your concentration will be the average compositions of your specimen, that is 0.28% carbon. Okay, so now you have to find out, and this is the direction of x. At the interface x is considered 0. Okay, so now we have to find out where the carbon concentration is, let's say 0.4, 0.4, and let's say this t2 is after 10 hours. So this location, this x, you have to find out. Okay, let me remove the other curve. Only one time curve I'm keeping, otherwise it will be confusing. So is the question is clear? what you have to find out?
Yes, sir.
Okay, so now how should we proceed for this? Anyone want to approach? Anybody?
Sir, we can apply the integrated form of Fick's second law.
Yes. What is that formula?
Sir, Cx minus C naught upon Cs minus C naught is equal to 1 minus error function of x upon 2 root over dt.
Okay. So this is the formula. So in this case, in case of first question, your Cx is also given. Cx is 0.48%. And what is the C naught? And what is the
Sir,
CS?
it's 1.2.
Which one 1.2? C naught or CS?
Sir, C naught is 0.2, CES is 1.2.
C naught is 0.28% and CS is 1.28%. Okay. C it means at the surface, what is the concentration of your carbon, and C naught means at the specimen that is far from this interface at this end, what is the compositions. So all the data are given. So now we have to find out X. Okay. And D value is not given, D naught is given. So how can we calculate the D value? Time is also given, time is 10 hours. So 10 hours means you have to write in the in terms of second. So keep this in mind. Never write the time in terms of hour in and put in the equation. Then you will not get the answer. So you have to convert the unit into second. So it will you have to multiply it by 3600. So that will be the time in second. Okay. So this will be 36000. This second. So now D naught is given, but D is not given. So how to calculate the D?
So we can use the formula D is equal to D naught into exponential of minus Q by RT.
Yes, so you have to use the Arrhenius equations. So D will be D naught into exponential of minus Q by RT. Now D naught is given, that is 2 into 10 to the power minus 5 meter square per second into exponential of, here also you have to keep in mind that Q is given in terms of kilojoule per mole. So here also you have to convert the unit. So you have to write it in terms of joule per mole, right? So it will be minus 142,000 in terms of joule per mole. And then what is the R value in? So R value is 8.314 joule per mole per Kelvin, right? And temperature is 870 plus 273. It is given in the degree centigrade. So here also you have to convert the unit and you have to make the temperature in Kelvin unit. Okay. So this little bit this small thing you have to keep in mind. Here you have to convert the unit of the time. Here also you have to convert the unit of the Q value, and also here you have to convert the unit of your temperature in Kelvin. So now can any one of you calculate this and let me know how much you are getting? What is the D value is coming at 870 degrees centigrade?
Sir, it's 6.5 into 10 to the power minus 12.
Okay. What will be the unit?
So meter square per second.
Yes. Achanta, you are getting, or do you have any doubt till now?
No, sir.
Okay. So now we got the D value. So we have all the values of this left hand, right hand side. sorry, in the left hand side, and in the right hand side we all know the d values, we know the t values. We have to calculate the x. So now let us write here. So cx, that is given, cx is 0.48% minus c naught. C naught is 0.2. Okay, and then cs, that is 1.2, minus c naught, that is 0.2, is equal to 1 minus error function of x by 2 into root over of db into t. db, like, you can write it as d also, like db means in the divisibility of the second phase other than the matrix. Okay, so d into t. So now this side is coming 0.4 minus 0.2 by, so 0.2 by 1 is equal to 1 minus error function of, so error function of x by 2 root over of dt is equal to 0.8, right? So now in the questions, one chart was given to you, this one, right? Here the y values and corresponding error function values were given. So now what is in our case, we got the error function value as 0.8. Okay, so now let us write here the chart, that is error function. So we got the error function value as 0.8, and we don't know the y value, but few values are given, that is corresponding to 0.85, 0.85. The error function value is, that is given, that is 0.7707, and also at 0.90 it is given 0.7970. Okay, so this value is basically so how can we calculate this y? Anyone?
So we can use the extrapolation method.
Yes, so we have to extrapolate and then we can calculate the y value. So just from looking in the table, can you guess how much, what value it will come? Means just around how much it will come? Because one of these value is very close to your given error function. Okay, so let us do the extrapolation. So if we extrapolate, so that is y minus 0. Let's say 85 divided by corresponding to this is 0.8 minus 0.7707 is equal to, let's say, 0.9 minus 0.85, and corresponding y error function y value will be 0.7970 minus 0.7707. Okay, so now from this we can calculate the y value. Y value will be 0.85 plus 0.8 minus 0.7707 into this 0.1 by 0.7970 minus 0.7707. Can anyone calculate it and let me know what how much you are getting? Before calculating also, can you guess near which value it should come from looking at the chart?
So around point 0.8.
0.8. Error function y value is 0.8. Okay, so you can see here also the error function y value is around 0.797. That means it is also close to 0.8. So that means your y value should come near at zero point 0.9. Okay, so from this also you can ensure or you can confirm whether you have calculated correctly or not. Okay, so now just calculate this from this and just let me know the answer. How much it is coming? Okay, so I did one mistake here. So it is 0.9 minus 0.85 it should be, and because the corresponding value I have written, that is 0.7707. Okay, so it will be 0.05. So anyone of you have calculated this one or not yet? Hello, hello. Am I audible? Hello, hello. So this value is coming 0.906. Okay. So now we got the value of y. Uh, so that y means x by, so y means x by 2 root over of d into t. So that is your y. So that is 0.906. Okay. So now from here we can calculate x is equal to 0.906 into 2 root over of dt. So that is equal to 0.906 into 2 into, so d value we have already calculated, into t is 36000. So now if you calculate this one, you will get 906 into 2 root over of d is 6.5 into 10 to the power minus 12 into t, it is 36000. So this is coming around 875 into 10 to the power minus 6 in meter. So in micron it will be around 875 micron. So the correct answer for the question 48 will be option D. Is it clear? Hello? Am I audible? Hello? Okay, so let us move to the second question then. So the second question is 49. So the question is how long in hour it will take to double the depth at which 0.4% carbon is reached. So in this case also the concentration is zero point 0.4 but your time is different. So you have to calculate after how long it will take the same concentration will be there, that is a 0.4% carbon but at the double of your depth. So let's say in this case your x was this one, so if you 2x, if you double the depth, so means at this location, let's say how long it should take. So as I have drawn the curve. So when the time with increasing time your curve goes like this and try to flatten out, right? So let's say this is the time t2, and then your concentration at this location is reaching 0 0.4. So now we have the equations. So from the equations we have cx minus c naught by cs minus c naught is equal to 1 minus error function of x by 2 root over of d into t. Okay, so now if you see that c at x, that is also 0 0.4, c naught is also 0.2, and cs is also 1.2. So LHS is, the value is same at both the cases when your time t is equal to 10 hours and when your time t is equal to t2. Okay, so that means this thing has to be constant, this ratio. So x by 2 into root over of dt has to be constant. Okay, because this is constant for t is equal to 10 hours and t is equal to t2, this is also constant, so this has to be constant. So for the first case, so your x is 875. Okay, sorry, let's write in terms of x only. So in case of first case, your x was x, and then 2 into d into t was 10 hours. Okay, so here I am keeping the unit of time in hours only. I am not converting because anyway we are taking the ratio, so it will be in the same unit. So because in the questions also you have to calculate the time taken in hours, so it will be better if you keep in hours only. Okay, so now in the second case your depth will be 2 times, so 2x. If you see the questions, so it is asked that how long it will take to double the depth at which the concentration of 0.04% carbon is reached. So if you double the depth, so it will be 2x, and again it will be in the, it will be 2 by dt. So d will be constant because in error function solution we assume that with concentration the d value is not changing. So because of that assumption your d will be fixed for this case also. Now you have to calculate the t2. So this will get cancelled out, this will also get cancelled out. So this x and x will also get cancelled out. So your root t2 is equal to 2 into root over of 10. So t2 will be 4 into 10, that means 40. So as I kept the unit in hours, so the final time that will take, it will be 40 hours. So in the second questions, the correct answer is option A. How long it will take to double the depth at which 0.48% carbon is reached. So is it clear, or if you have any doubt you can ask. Actually the problem is I cannot hear your voice, so you can write in the chat box also if you have any doubt. So, do you have any doubt in any of the questions that are solved today? Okay. So, now okay, then if you don't have any doubt, then we can close the session for today, and we'll meet again on the next Sunday then.